Okay, please share your screen. Ah, nice, 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 nice. Okay. Ah, good, 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 good. Ah, and this. Ah, good. Okay, good. So that's how to create the symbols. Okay, good. Let's continue. The others are taking quite some time to join. Okay. So, can you see my screen? Can you see?
Yes, I can.
Yeah. As I told you, you can always make this better. This is slightly smaller. I'll try to center it. Can always make it better. It's not to be perfect, but just have something which makes sense. Okay. Okay, that's it. I told you you are using a grid of 10 millimeters, so you type G. Okay, make it that. You can make it as as perfect as you could possibly do, but that's fair enough. Or that try to make it too perfect, you'll end up spoiling it again. Okay, just have something like that. That stands for an LED. There are also other symbols online which you can use. Okay, I had done USB-C. I had done USB-C. This is USB-C. I had done this other chip, which is W25Q. That we had done the typical. We've done this today. We've done a capacitor. We've done an LED now, polarized. We've done the other capacitor. Okay, 3.3 volt regulator, 4x1 capacitor or header. Okay, and 1020x1 LED. Can you see those? Can you see?
Yes.
Yes, so I want us to go to, so there are few parts which we have not done. We've not done the button. I've done this. I've done this. I've done this voltage regulator. So I've not done the button or the switch. So let's do the switch and then we do this one. Okay? Can you see this? Can you see
Yeah.
this? Yes. So we do that. We do this over here. And then we also do the button. Okay. So let's start by doing this. It's very simple, or it's very similar to the one which we did. It's almost similar to this. So you add, do you see the component? They call it's a triac. Have you guys heard of something called triac? Hello? Have you heard of something called triac?
Not really.
Okay. Okay. So let me, it is BAT54C. So you can Google it, BAT 54C. Okay, it's a Schottky barrier diode. So this planar Schottky barrier diode with an integrated guard ring, mountain, whatever. So you should read the data sheet. I think this is a good introduction. We can start by reading the data sheet here. So I don't want you to. So basically, it's an electronic device that is used low volt, encapsulated in SOT23 package. That we will learn about this packaging when we were doing the symbols for the PCB. So this is how it looks like. It has got these symbols like this, and then the cathode, anode, cathode. So current can flow in one direction like this, and then also this side like this. But then it's similar to a rectifier. Do you guys know a rectifier?
Yes.
Yes,
For
I do.
yes, a rectifier is covered in Form 4 work. In Form 4, I think, or Form 3 to make some kind of DC to analog, DC to AC conversion. Okay.
yeah.
Anyway, so don't worry about what it does. For now, we are just going to focus on building. It's what is called a Schottky barrier. So you copy that and then create the new part as we had been creating this new component. So you paste it there, BAT, like that. Okay. And this is where now it has got 3 pins. So you copy this upper. Then there is also another one here. And then this other one, I told you, you press the tab, the tab key, and then it will give you those. Okay, you start by this, you start by hiding this numbers, we don't need them. Okay, then these ones, you can decide to have them as 200 is okay. 200, 200. And remember, this other one should be rotated. Okay.
I had a question.
Yes.
Which direction? You see, the pin has different ends. One is like a plus side, the other one is having nothing. Which direction should be connected to the component?
Okay.
That's the issue.
So the pin where there is, can you see the side which has got some dots here?
Yeah, yes.
Yes. So this one should be connected away. This is where you are going to connect the next component. So
Okay.
yes, this one, this is where you're going to connect
So,
the next component. Even this other one, you see here iko na hizi tatu with 4 pins. So that is where you're going to connect your next component. Okay. 200. Okay. And then this one, you bring it like that. Okay. Let's go to the symbol again. Can you see? It's just like this two triangle. It doesn't have to be, it doesn't have to be filled in, but let's try now using the polygon. The polygon, you click. Can you see? We can check border small. You change the border to be small. And then fill color. Fill color to me a blue. Mnaona vile inakaa? Have you seen?
Yes.
Yes, you can even make it smaller. I don't know whether making it smaller would make it look way better. Is it better? I think it's better. Then you copy, control paste, and then you rotate using the tab. Namna hiyo. And then you need a line to join them. Okay. This one, I think even 100 is enough. 200 yote ni refu. 200 is long. 100 is okay. It's just how you feel. There's something which is missing. What is missing? What is missing, guys? And then you should include some kind of uniformity. What is missing, guys? In the symbol.
The lines, if I'm not wrong.
Yeah, these lines which were here.
S-shaped lines, yeah.
Okay. Ndio. Can you see? Then you can press shift and then copy, control C, control V, and then you but was it like that? Hiyo iko hapo. Kama hiyo inasumbua, you can draw a new line. Is that even the symbol? There is something which zinaangaliana. No, they are looking away. This one is looking at the back. It's not supposed to. And remember that these ones are just madoido. It's nice to have, but it doesn't affect like how your PCB will look like. So it takes a lot of patience and practice. Okay. Can you see? Can you see, guys?
Yeah.
So these lines can make them blue. So I'm telling you, these are just to make your work look beautiful. So that is how it should look like. These lines, maybe they don't become very small. No, I think that's just okay. If you don't make them too thin. Okay, I think that's okay. Okay, are we together?
Yeah.
Yeah, you can make it better. Okay, by doing a lot of practice, you can make it way better. Can make yours way better. Okay, nitaachia hapo. But we can also import this. I'm going to show you there are also some more beautiful symbols, but this is how they are done. This one could be a lot higher, maybe 200. Yeah. So that's how the symbol looks like. Okay, that's that. And then we are going to look for switch, or which is the button. So here we're going to look for the switch. Switch. We'll also look for the switch. And the switch, if you remember, it's also slightly similar to what we have. The switch has got uh, two, two pins. So rotate this. Like that. And then this other one. Okay, like that. And then you can, first of all, hide these numbers. Hide the numbers. We don't need it. Okay, I hope you are looking at the symbol of the switch, how it is. They are having some kind of some like two boxes. Can you see that? Can you see?
Yes.
Yes. Okay. something of that sort. Then you can copy this, paste, so that it is there. Then it is like that. And then the switch has got circle. So circles, ndio hii mnakuja hapa, full circle. You make it as small as you can. Okay. Umeona vile nimechora hiyo circle?
Yeah.
Yeah, and then you copy, paste. And then there is a line which is from one circle. It is at an angle. Like that is it. Trying to put it somewhere at the center. So delete hii. Peleka hii. Then this one's properties. Liquid blue. And then this one's tunaweza reduce. We can reduce them to 100. Is that good enough?
Yes. Yes.
Yeah, that's good enough. The switches, that's good enough.
What command were you using to rotate a selection? Let's say you've selected something, you want to paste it, you've copied it and you want to paste it. How do you rotate the
You use the tab, not
tab?
nini. How do we call this?
Spacebar.
Spacebar.
Or spacebar?
Mm,
Okay, thanks.
yeah. Sawa. So ndio hiyo. We are not going to be perfectionist. We are going to make something which can work. Okay. Is that okay?
Yes.
Yes. So now we are going to go to our schematic and start drawing. Normally, when you come to a schematic, you come here to schematic, which you have there. If you look at how it is, and I'll open it. The schematic. Think I don't have it opened. Can you see it? Everyone, can you see it? Can you see?
Yes.
Yes. So it's going to be divided into sections. You're going to divide it into sections to make it easy. And then you put this label like boot. You put, these ones are in Chinese, but doesn't matter. This one is like some switches, some headers, some USB, and then that. Okay. So let's just try to put them. And so you come here to schematic, and then you come to, on the left-hand side, select components. And if you have been following, you will see you have your parts like your STM32. You place it there, then you press escape. Are we together?
Yes.
Then we have got the 20 headers. You copy them like that. There are two. Can put it here. So you put them like that. Okay. Then there is the header of 4x2. You can put it even down here. Like the headers can be put together, or it doesn't matter, but you can just put it no matter how you want. Then you have the USB-C, naeka somewhere there. Okay. Then we have got this chip, which was the it's I see it's like a memory. Can put it there. We have got the switch. We are using so many switches. So unaweka switch hapo. And then BAT, this one is that Schottky diode. Put it also somewhere there. The main components, in short: polarized capacitor, voltage regulator. You put it over there. Okay, guys? Are we together?
Yeah.
Yes. So we are going to connect them together. There is also STM32 4x2 capacitor. We also going to need some capacitor. Okay, like that. Resistor type 2. We are just having the normal resistor. LED. Pia tuko na LED. We also have an LED kwa hapo. Okay, ndio hiyo. Are we together?
Yeah.
Yeah, so I'm not going to finish all of it. I will give you as a challenge to finish it. But before we do this, I'm going to show you how you can separate it using, you first of all, you separate it using, you have a line to divide your schematic. Mnaona? Can you see?
Yes.
Yes. And then you can make them thicker. You make the line thick. Okay. Yeah, you make the line thick. You, you'll come to here, then properties, the line. So line can be medium, and for some case you like blue. So you can copy that. None. Can you see that? Then okay, like this. Okay. Copy. You can always rechange it. Okay. Mnaona?
Yeah.
Yeah. So this one also make it blue, make it medium. Sawa. Okay, we bring that LED inaweza kuja hata hapa chini. Okay. This one somewhere here. Okay. Then one last line. We are going to take it like that. Okay. Can you see? Umeona?
Yes.
Okay. Then we are going to reuse these parts. Okay. And then now you put a text. So you come here, place text. So here you put text as many as you want. So let's start with this. This is USB, USB-C. Sawa, umeona? Okay. Can you see?
Yeah.
Yes. Okay. And then you can always even increase its size if you want the font ikuwe kubwa. 0.18. Okay. You can copy that and then you paste here. This one is microcontroller. Now this. So, can you see? Are you able to see?
Yes.
Yes.
Then this, change the color, medium. Okay. So this one was not microcontroller. This was USB. Ah, yeah. This one, the down here is headers. Sindio? So, okay, this copy, unaweka hapo chini headers, headers. Sawa, hiyo ni hii pia ikiwe moja yao. We are going to find a way to put it, squeeze it in there. Okay, guys, are we together? Yes. So this was voltage regulator. So I want you to do this. So that's the voltage regulator, this. Size 18. Okay?
Okay.
Yes.
Right.
So you do this and then when we meet, but it is very easy to connect them now. Okay. So for example, if I just show you from the diagram, we have got PA0 and then key, the switch, and then ground. Can you see this? Can you see? PA0 and then ground, eh?
Oh. Uh-huh.
So actually there's no resistor here. We'll use that. So you come and click, this is the ground. Ground ni hiyo. and then you rotate it like you press that, then inawekwa hapo, and then this is the wire. You place a wire, connect here to there. Are we together?
Yes.
Okay, then hapa mkishafanya ni rahisi. You click like that, and then we have a label. Okay, it's found here. Place here. Can you see that? Okay, PA 0. Can you see that? PA 0. Umeona? Can you see? Guys, can you hear me? You can hear?
Yeah,
Yes. Okay. So I want you to copy this schematic the way it is, and then you fill it in. Okay. Can I share it? Can I share it with you, and then you build on top of what I've done? Or
yes,
everybody,
please.
you will be able to do your own? You'll be able to do your own. Mnajiamini, si ndio? Hello guys.
Uh, uh,
Mnajiamini?
Yes.
Okay, okay. Yes. So go work through it over the weekend. Work on it maybe up to the weekend. Then if I get time over the weekend, we can finalize. We will now just copy them quickly, and then we start the next part, which is the schematic the footprint. Footprint, we are going to create a footprint, and I'm going to show you how the footprint look like. Like for example, for the sister, there is how the footprint look like. Okay?
Yes.
Are we together?
Yes.
Yes.
Yes. So finish this schematic for your case. Finish it by least over the weekend. Mkuwe mmefanya kitu. And you make it neatly, you separate it like that, and then you write it, make it even neater than mine. Okay?
Yeah.
Yes. Okay. See you next time. I'll upload this recording.
Okay. See you.
Okay. Thank you.
Right.